Hi, I'm Chris Engelhardt,
And I'm Chris Yurkowski.
and we're with the Verizon Network Applications Group. And essentially what that means is that we run various different typical mobile network applications on VCP, which is Verizon's internal network cloud. And today we're going to be speaking with you from a perspective of what we call the tenant operators. So we don't have administrative access to OpenStack. We don't have access to the application source code either. It's our job, though, to get these VNFs into OpenStack and to operate them on a regular basis. Some of you may have read our abstract. We did have to cut it down a bit to fit in 10 minutes, but if you have any questions on anything there, any burning questions, feel free to ask us about it afterwards. But today, yeah, we're going to focus on our journey of onboarding large applications into OpenStack. So with that, Chris will get us started.
Hi. Thanks, Chris. Hello, everyone. Thanks for coming. As you can imagine, telecom applications differ from your typical OpenStack enterprise application in a number of ways. There's regulatory compliance, high packet per second requirements, strict security concerns, and latency issues. But the issue we're going to concentrate on in this talk is their sheer size and the ramifications that has in how you deploy applications like this in OpenStack. Telecom applications often need to support hundreds of millions of subscribers, and while that does not make them unique in the OpenStack world, it still puts them in a special tier. And that large size forces you to have to deploy them across multiple OpenStack instances or VIMs. And there's really two drivers for that. First of all, they're too big to fit in one VIM. They simply don't fit. But beyond that, in order to achieve the resource optimization, the resource savings that OpenStack promises, you need to deploy them over more than one VIM anyway. Virtualization, as you know, has inherent overhead, but the idea is that you can more than recoup that overhead by deploying a heterogeneous mix of applications into your VIM, and different applications will have different requirements. Some will be CPU intensive, while others are quiescent. Some will be using a lot of disk IOPS, where others are using a lot of RAM. And through this mix of applications, you can get better resource utilization than if they were all using dedicated hardware. But if one VIM is consumed entirely by a single application, you're not going to be able to achieve those savings, because all the VMs are going to need, be subjected to the same demand profiles, and they're all going to be busy at the same times and use the same types of resources. So you need to distribute your application across multiple VIMs, and beyond that, you're going to occasionally need to rebalance them. As you add additional VIMs to your data center, you're going to want to distribute them across the new larger set, and when you add a new application, you don't want to put it all in the newest, emptiest VIM. So you've got several levers that help you achieve that goal. Of course, if you avoid static IP addresses or software-defined networks can help, because then you don't have to redo your network design. But you're still going to need tools that help you efficiently and easily deploy and redeploy applications across multiple VIMs. And if your software provider does not supply that as part of their standard package, which we found is generally the case, then that's development you're going to have to do yourself. So Chris is going to explain some of the things we've done to try to solve that for some of our applications.
Thanks, Chris. Oh, wow. So as Chris was just discussing, to make large telecommunication applications work in an environment where you have perhaps multiple VIMs per data center that are smaller and application doesn't fit, you're going to have to split them across different VIMs, and that presents its own operational challenges. So we're kind of evolving through a journey with that through different stages. When we first started, we literally just, it was like log into Horizon. We have all these different tenants or projects and different VIMs. We're downloading all these RC files. We're, logging into this VIM, running that operation. We devised kind of a very crude way of putting them together into a simple Python file, which I'll show you briefly. We started using the more standard from OpenStack clouds.yaml, which is great. And we're working now on doing more to try to manage, again, these single applications across multiple VIMs in database-driven ways, as well as with our vendors to supply us with VNFMs for multi-VIM support. So yeah, like I said, when we started, we needed something quick, so we cobbled together something pretty crude, but it worked for us, which was to, instead of sourcing an individual RC file, you source one file, and as you can see, you just put in user, password, credentials, you select which location, and then tenant, in addition to specify which VIM in that region it's in. And again, to make it easier on our operations folks who are responsible for this specifically, give them a little shell prompt so they can keep track of where they're doing what, and be able to use the OpenStack commands just, after having just basically taken a basic course on OpenStack. And so that was pretty helpful for us getting started. Over time, I learned about this clouds.yaml thing, which maybe some people at this conference were involved in setting that up. And the clouds.yaml is great because it is a standard format which is used across a variety of different OpenStack applications, client libraries, and other tools. And it's a standard way of specifying information about the different clouds you're going to connect to. So that way, if we want to use a different tool, even a different programming language, or we need to move from one VIM to another, or we need to change the credentials, we only have to change one thing. We don't need to reconfigure multiple different tools. We don't need to do things like that. Another kind of cool feature of this clouds.yaml, which I think is probably even less known, is the ability to split up information across different YAML files. So as you can see here, here's just an example. Clouds.public, you can specify one entry per VIM, and you can specify things like the Keystone API version and other things that are per VIM there. And then your traditional clouds.yaml, you can just reference that by, you see I have it there with the profile. I'm referencing the profile from the clouds.public.yaml. And then you can have a third file, secure.yaml, so you don't actually have your passwords in there. And so you can check the other two up into version control, but then kind of keep secure.yaml in a more secure place. And that's basically it, the 10-minute version of our journey with OpenStack and doing the large applications. Any questions? Okay, our colleagues are going to be presenting in, I think, 5 minutes on VCP itself, if you're interested, up in 401 or somewhere up there. Thank you.